Our story begins not in written pages, but in layers of ancient Earth, with a creature that stands at a crossroads of evolution. This is the story of Australopithecus afarensis, a name that echoes from a time 3 million years before our own. You might have heard of Lucy. Lucy was an Australopithecus afarensis. Australopithecus afarensis represents a pivotal taxon in the study of hominin evolution, defining the Pliocene adaptive grade characterized by the decisive emergence of habitual bipedalism, coexisting with primitive cranial and developmental characteristics. The species name, formally established in 1978, translates literally to southern ape from Afar, referencing the Ethiopian region where crucial specimens were first recovered. To understand afarensis' place in the deep history of our family, we must see it as part of a group known as the gracile Australopithecines. The term gracile refers to their lighter build. Unlike their robust relatives who evolved massive jaws and chewing muscles, these hominins had a more slender frame, a distinction that hints at a very different evolutionary path. Our knowledge of this ancient relative is not based on speculation. It is built bone by bone from fragments of the past unearthed from the African soil. The story of its discovery is a chronicle of patience, scientific insight, and remarkable fortune. The timeline of discovery is marked by 3 pivotal moments. In 1974, the world met Lucy, a partial skeleton that would redefine our understanding of human origins. 4 years later, an almost ghostly set of footprints left 3.6 million years ago was found preserved in volcanic ash at Liadali. Then, in the year 2000, the discovery of Salam, a fossilized child, offered an unprecedented window into the growth and development of these ancient hominins. These extraordinary discoveries are clustered in East Africa's Great Rift Valley, a true cradle of hominin evolution. At Hadar in Ethiopia, a team led by Donald Johanson uncovered a treasure trove of hundreds of fossils. In Tanzania, Mary Leakey's expedition found those indelible footprints. And at Dakika, Zarasene Alamseged found the child Salam. Each site and each scientist added a vital piece to the puzzle. One of the most astonishing finds at Hadar came from a location known as AL333. Here, paleoanthropologists found not a single individual, but a group. The fossilized remains of at least 13 individuals, males, females, and young, who appeared to have perished together. Nicknamed the First Family, this collection offers a rare and poignant snapshot of a Pliocene social group. Together, these key specimens formed the bedrock of our understanding. Lucy, at 40% complete, served as a Rosetta Stone for their anatomy. The First Family provided a glimpse into population dynamics. The Liatoli footprints captured their behavior frozen in time, direct, undeniable proof of an upright gait. And Salam, the Dakika baby, revealed how they grew, a crucial link between their world and our own. With these fossils laid out before them, scientists could at last begin to piece together what this creature looked like. What emerged was a true anatomical mosaic, a being of 2 worlds, blending features of an ape-like past with adaptations pointing toward a human-like future. The contrast is stark indeed. The skull housed a brain not much larger than that of a modern chimpanzee, set in a face that projected forward. Yet below the neck, this skeleton was fundamentally different, radically re-engineered for a life spent walking on 2 legs. The fossils also reveal a significant difference between the sexes, a trait known as sexual dimorphism. Males were considerably larger and more powerfully built than the smaller, more lightly constructed females. This size difference, also reflected in their teeth, suggests a social structure quite different from our own. An examination of the upper body reveals the ghost of an arboreal existence. Long arms, powerful shoulders oriented for reaching overhead, and long, curved finger bones all speak to a life that still involved the trees, perhaps for food, for safety, or for sleeping at night. They had not yet fully abandoned the world of their ancestors. But if the upper body whispered of a life in the trees, the lower body shouted of a revolution on the ground. The pelvis was no longer long and narrow like an ape's, but short, broad, and bowl-shaped. The legs angled inward to the knees. These were radical, unambiguous adaptations for a new way of moving through the world. This brings us to their single most defining characteristic, habitual bipedalism. The commitment to walking on 2 legs was the great evolutionary gamble of this species, a move that set the stage for everything that followed in the human story. The first line of evidence is the pelvis itself. In apes, the long hip bones stretch up the back. In afarensis, they became short and broad, wrapping around to the sides. This crucial shift repositioned the powerful gluteal muscles, transforming them into critical stabilizers and preventing the body from toppling over with every step. The second major piece of evidence is found in the knee. The femur, or thigh bone, angles inward from the hip. This is known as a valgus knee. The angle ensures that as they walked, their feet landed directly beneath their center of gravity, providing a stability and efficiency that a straight-legged ape could never achieve. And the final, most dramatic piece of evidence is not a bone,
but a trace. The Laetoli footprints show us their gait in action. We see a clear heel strike, a transfer of weight along a modern-looking arch, and a final push-off from a big toe that was in line with the others, a toe built for propulsion, not for grasping. This was the foot of a dedicated walker. When scientists put all the evidence together, the conclusion is clear. Australopithecus afarensis was a proficient, energy-efficient biped. Its walk might have been subtly different from ours, perhaps with slightly more flexed knees and hips, but walking on 2 feet was, without question, its primary mode of locomotion on the ground. We have reconstructed this remarkable creature, a biped with an ape's head, walking in ancient land. But we must now ask, what was that land like? How did it survive in the lost world of Pliocene Africa? The story of its survival is etched into its teeth. Afarensis had large molars coated in thick enamel, adaptations for a diet that included tough, abrasive foods. Microscopic scratches and pits on the tooth surfaces confirmed they processed fibrous plant matter. This did not mean it was all they ate, but it meant they could, a crucial advantage when softer fruits and leaves were scarce. And this points to the secret of their success: adaptability. Their fossils are found in geological settings that reveal a wide range of ancient environments. From dense woodlands to more open savannas, Anthropus afarensis was not locked into one specific niche. It was a versatile generalist, a key trait that allowed it to thrive for nearly 1 million years. When we step back to view the entire picture, the legacy of Australopithecus afarensis is immense. This was the species that fully committed our lineage to walking upright. Its body is a classic illustration of mosaic evolution, a modern-style body plan paired with a primitive skull. Its success across a wide range of environments set the stage for all that was to come. For these reasons, it remains the best candidate we have for the direct ancestor of our own genus, Homo. Ultimately, the fossil record of afarensis, despite retaining primitive features like a chimpanzee-like maturation rate and pronounced sexual dimorphism, established the successful baseline from which the lineage leading to the genus Homo later emerged.